Logical Positivism. In the last presentation, we looked at the lead-up to logical positivism, and we saw that it ran right through Albert Einstein. Now, in 1919 at the University of Berlin, Albert Einstein gave a seminar, his first ever, on the general theory of relativity. One of the students in that class, one of the 8 students, was a man named Hans Reichenbach. Now, Reichenbach had been an engineer, a radio engineer, served in World War I, went back to take more classes, and sat in on this seminar with Einstein. It changed his life. He and Einstein became friends. He realized how fundamentally radical Einstein's theory of relativity was and what it meant for philosophy. And so Reichenbach went on to become one of the first modern philosophers of physics. Well, he tried to get a position there at the university, but the university didn't think of philosophy of science, much less philosophy of physics, as real philosophy. And so the philosophy department refused to have him. Einstein thought this was an outrage. He appealed to the philosophers. They rebuffed his move. So he went to Max Planck, who was the head of the physics department, and had a new chair created in the Foundations of Physics. So Reichenbach began his philosophical career actually in the Department of Physics. Now, there in Berlin, he found a number of like-minded figures who would create a circle around him, the Berlin Circle of Logical Empiricists. These included people like Karl Hempel, Kurt Grelling, Richard von Mises, and occasionally the great mathematician David Hilbert. At the same time as Reichenbach was organizing his group in Berlin, Maurice Schlick started organizing one in Vienna. Schlick had a PhD in physics, having studied under the great physicist Max Planck, who pulled some strings and got him a position at the University of Vienna. He had been corresponding with both Einstein and Reichenbach and knew what was happening in Berlin, so he created his own circle there in Vienna. They called themselves the Wiener Kreis, the Vienna Circle of Logical Positivists. Its members included Hans and Rose Hahn, Otto Neurath, his assistant Rudolf Carnap, who would go on to become the sort of spokesman of the group, Herbert Feigl, Philipp Frank, Karl Menger, Friedrich Waismann, and a very young Kurt Gödel. The group would meet Thursdays. They would discuss philosophy and they would read books together. Twice they worked through Wittgenstein's Tractatus. Now, they thought it included incredible insights, but at the same time, especially the ending, they thought was deeply problematic. Neurath especially thought it shot through with metaphysics, which, for the Vienna Circle, was a nasty word. They would read aloud one of the propositions in the Tractatus, and Neurath would thunder, "Metaphysik," metaphysics. This was making Schlick angrier and angrier. So Carnap, ever the peacemaker, said to Neurath, maybe instead of shouting metaphysique, you could just say M. So for the rest of the session, Neurath, as the rest of them were trying to have a conversation, just hummed, This was the nature of the group. It was radical. They knew they were recreating all of philosophy. As they read the Tractatus and they came across these propositions that weren't clearly understood, they thought, hey, we're in Vienna. Wittgenstein is in Vienna. We'll just go see him. Wittgenstein said he would see Schlick and one other person. It would be Friedrich Waismann. They would go, but here were the rules that Wittgenstein laid down. No questions, no challenges. You may come, you may not speak. I will talk about whatever I feel like speaking about. Needless to say, the Vienna Circle didn't find the meetings terribly helpful. What they did do then, after working through the Tractatus, was to see philosophy as Wittgenstein did, in the sense of being an activity whose focus was linguistic clarifications. And what they would then seek to do is to rebuild all of philosophy on this basis. The view the Vienna Circle would create is what has come to be known as logical positivism. Now, the best way to think of logical positivism is like cleaning out your refrigerator. Okay, so how do you clean out your refrigerator? Step one, you open the fridge and the freezer door, you take everything out and you put it on the ground. You then go item by item. You sniff it, you touch it, you taste it, you see if it's good or not. If it's awful, it needs to be thrown away, you throw it in the trash can. If it's still good, you put it back on the floor and you go item by item to see what stays and what goes. Now, once you have the set of things that need to stay, you now have to divide them. Okay, over here is all the stuff that goes in the freezer. Over here is all the stuff that goes in the refrigerator. Now, you take all the stuff that goes in the freezer and you organize it neatly in the freezer. Done. Then you take all the stuff that goes in the refrigerator, you reorganize all the shelves in the fridge, close the door, done. That is logical positivism. Okay. 4 parts to what we just did in cleaning out your refrigerator. Those 4 parts are the 4 pillars of logical positivism. The first is what's called the criterion of cognitive significance. That is the test for which propositions are meaningful and which propositions are nonsense. That is, you go one by one and see which ones to throw in the trash can and which ones to keep. Once you have all the ones you want to keep, we need to divide them into 2 parts, what goes in the freezer and what goes in the refrigerator. In other words, what are necessary propositions and what are contingent propositions, right? This distinction goes back to Kant. They're going to keep that between necessary and contingent truths. You now need an account for the necessary truths. That is, you need a way to organize your freezer, right? That is, you need a theory of necessary truth or a philosophy of mathematics. They would pick logicism for this. Then you need to organize the refrigerator. That is, you need to take all the contingent truths and find some intellectual foundation to underlie their truth. Right? That's going to be a philosophy of science. And for that, they used what we'll see was called Bayesianism. So, cleaning out the fridge, just another way to think of logical positivism. So let's go through these 4 pillars one by one. The first one is the criterion of cognitive significance, right? This is the rule that lets us determine what we're going to keep as meaningful and what's meaningless nonsense and just gets thrown into the intellectual trash can. Now, the cognitive significant part is what we call positivism. Positivism is the view that all that is real is that which comes in through the senses. Positive just means observable, right? Literally, it means seeing is believing. That is, if it's not something that I can observe, it's not something we claim to be real. Now, the problem here, of course, is that science uses all sorts of what we call theoretical entities. Forces, atoms, things that we don't directly perceive, but yet are used in our scientific theories. How do we get to them if we're going to be positivists? But it gets even more complicated, right? In that all I have are sets of observations, and from them I use them to create even the normal objects of everyday experience, things like chairs. So, how do I go about talking about the world if we're going to be restricted to our observations? And here is where they adopt the first version of the criterion of cognitive significance, what we call the strong version. And what that says is that a proposition is meaningful if you can break it down to the observable parts and tell me what I would have to observe for it to be true. So when I say there is a chair in front of me, what I literally mean is I have a complete set of conjunctions of individual possible observations. And if I look at the world and I see all of those observations, then I know that it's true. So when I say I see a chair in front of me, what I mean is I see brown here, I see a different shade of brown here, I see things that look like legs there. So the idea is that you can tell me exactly what I would have to see in order for that proposition to be true. If you can do that, then I have strong confirmation. Your proposition is cognitively significant, and therefore it is meaningful. So, what is true is what I can perceive. That is, what I can confirm through observation. The problem is that science, which is, remember, the epitome of rationality, has an aim, has a goal, and that goal is to give us universal laws of nature. Laws of nature talk about potentially infinite numbers of things, right? So the law of universal gravitation holds for everything. So how many things would I have to observe in order to confirm that? Well, an infinite number. Can I observe an infinite number? No. So therefore, the laws of nature, the thing that science strives for the most, isn't even possible under the strong version of the criterion of cognitive significance. Oops. Okay, so they move to a weaker version, right? The weak version of confirmationism says I don't need to know exactly what observations I would have to absolutely show it's necessarily true, but rather I would need to know what observations I would have to know that it's probably true. What I need to know is what I would have to see to have good evidence for it. Well, this is nice because it succeeds in ruling in science and the laws of nature while ruling out metaphysics, right? What would I need to see in order to know the existence of God, to know the existence of space, to know that humans have free will? What it does is, as Wittgenstein hoped, ruled out much of philosophical discourse as pseudo-questions answered by pseudo-statements, right? A pseudo-question is a question that doesn't have a real answer. A pseudo-statement looks like a sentence, sounds like a sentence, but doesn't really say anything. We need to be able to reduce all of our propositions down to combinations of observation reports and logical connectives. If I can do that, now I have meaningful propositions, and much of philosophy can't do that. So, some philosophy is real, that which can be understood in this logical positivistic way. The rest of it, just highfalutin, fancy-sounding nonsense. Let's look at the next two pillars. One is the synthetic analytic distinction. Right? This comes right out of Kant, and the logical positivists thought this was one thing that Kant got absolutely right. We do have to distinguish between necessary truths, the sorts of truths that you see in mathematics and logic, and contingent truths, the sorts of truths that we see in science. And what we need are accounts of both of them. What are these truths and how do they work? Okay. So if we look at the analytic part, right, these are our necessary truths, they turn to Bertrand Russell. In fact, Rudolf Carnap from Vienna wrote to Russell because they couldn't get a hold of a copy of Principia Mathematica. Now, this was so expensive, and Cambridge University Press had printed so few in its first print run that Russell didn't have one to send to him. So he hand wrote an extended introduction and summary of everything that Russell and Whitehead did in Principia Mathematica. And the logical positivists read over it, ultimately were able to read PM and thought, this is right. Russell had done it. He had solved this one problem. Logicism would be the analytic truth for the logical positivists. Okay, well, what about the other side? What about synthetic truths? Well, the problem is we can't prove them, right? The cognitive criterion of cognitive significance says it's not a matter of proof, it's a matter of evidence. So we need to understand what we mean by evidence. Well, there is another kind of logic, inductive logic. So Russell formalized deductive logic and used that as the foundation for our understanding of necessary truth. Maybe that's what we need to do on the other side, formalize inductive logic, and that will let us to do for the synthetic side what logicism did for the analytic side. Well, anytime you deal with inductive logic, it has its own issue. It's a big one. It's one that Kant wrote, "It awoke me from my dogmatic slumbers." This problem is, dun-dun, Hume's problem of induction. So what is Hume's problem of induction? Well, David Hume was a philosopher of the generation just before Kant. And like Kant, he divided sentences into our two groups, right? Analytic propositions that are true because of their form, and synthetic propositions that go beyond it. So, he starts by thinking about these synthetic propositions, right? These sentences that might or might not be true, these contingencies that we accept. And he says, I can divide these into two different groups. There are ones that I can just directly observe. Things like grass is green, the sky is blue, the cat is on the mat, right? These are things that I know are true because, look, I see them. Now, he says these are all going to be propositions that are really based on a couple of connections. One is similarity. When I say the sky is blue, what I'm saying is the color of the sky is like these other things that I call blue. The other class are based on what he called contiguity, right? Contiguous just means next to, and it could be next to in space or next to in time, right? The mug is on the desk, or you flinched after I smacked you. But then there are the ones that I don't directly observe. And these are propositions, he says, that involve the notion of cause and effect. Right? Now, it's one thing to say that event A happened and then B happened. That is, B followed A in time. But to say that A caused B is to say something more, right? That is, causation is more than just time order. There's some special connection, some magical force that happened that forced the first part to give rise to the second part. What is the study of causation? Well, that's science, right? Our causal generalizations are the laws of nature that science aims at. So if we want to justify scientific beliefs, we need to know what are the truth conditions for these non-directly observable synthetic propositions that involve cause and effect, right? You can look as hard as you can, right? A colleague of mine, Hanno, used to teach here at Gettysburg and used to take his philosophy classes out to watch baseball games. And said, watch the batter, watch him hit the ball. You see him swing, you see the ball go. Do you ever see the causing? Hume says, like Hanno, that we don't see the causing. We see event A, the swinging of the bat. We see event B, the flying off of the baseball. But you never see the causing. The causal nexus is not something we directly observe. But if you can't see the causing, how do you know it's there? If all we know is that B came after A, how do we know that it was A that caused B and not something else? So, consider the conversation that happens between these two people. Hey, what do you think's going to happen the next time I drop this pen? I think it's going to fall. Yeah? Why do you believe that? Observation? Well, that can't be observation, right? You haven't seen it drop the next time because it hasn't happened yet. Oh, right. It must be deduction. Well, it can't be, right? Deduction is non-ampliative. It only infers from what you've already seen to something smaller. Oh, right. So it must be induction. Every other time you've dropped the pen, it's fallen. So inductively, I believe it'll fall this time too. So why do we believe inductive logical work? On the basis of deduction? Well, it can't be. Inductive conclusions are ampliative, and deduction only works for non-ampliative cases. Oh, right. So it has to be induction. You know, whenever I make inductive inferences from evidence, it's usually right. So it'll probably work in this case too. But wait a minute. That's an inductive inference. What justifies that inductive inference? Deduction? Can't be. Inductive conclusions are ampliative, and deduction only works for non-ampliative cases. Oh, right, it's induction. Whenever I make an inductive inference from evidence, it's usually right, so it'll probably work in this case too. But that's an inductive inference. What justifies it? And on it goes. Right? There seems to be no way to get out of this circle, this infinite regress. There's only two ways you can justify something, deductively or inductively. And with inductive inferences, you can't justify them deductively, but if you justify them inductively, you're using induction to justify itself, which means it has no justification. That's the problem of induction. But without induction, we have no notion of evidence. Without the notion of evidence, we can't have weak confirmation. Without weak confirmation, we not only no longer have science, we no longer have the meaningful propositions. The whole thing comes tumbling down. So we have to figure out some way that we can get around this problem of induction. The positivists thought, well, maybe we can solve the problem of induction deductively. Well, wait a minute, I thought you can't do that. Well, maybe we just need a different tack. Maybe what we need to do is understand inductive logic formally. That is, we model the approach on Russell and Frege's logicism. We need a sort of deductive logic that underlies inductive reasoning. Well, how could that be? Well, inductive reasoning is what's probably going to happen. Ooh, that's the trick. Probably. We're talking about probability. And probability, that's a branch of mathematics. So what we need is a mathematically rigorous theory of probability that can do for contingent propositions what Principia Mathematica did for necessary propositions. That's it. If we come up with a firm mathematical logic of probability, now we have an absolute foundation for contingent truths, and the whole thing could be saved. Well, they looked at the history of probability, and what stood out was the work of Thomas Bayes. And so they tried to develop this, what was called Bayesianism, into a version of what Russell and Whitehead did. If they could succeed in that, then it seems like we could have all four of these pillars operative, and logical positivism would succeed as the new philosophy that firmly and completely establishes the foundation for all reasonable belief.